Yeah, that's right. Thanks, Crystal. Okay, so yesterday we talked about surface area. So we do have our, composite shapes and surface area. So we have our answers up on the board. You can see that in this homework problem, they broke it down with boxes. So they broke it down so you knew what you're multiplying together, and and then what the outcome was of that, so what the product was, and then also the total area, adding those three figures together to get 36 meters squared for the park area.
Or is that like the same as that?
Any questions on number 7? We've been to my husband's closet for Friday shirts now. That's what we are. Such a. It's when I dip into his closet on a Wednesday that we're gonna, it's been bad. Okay, so here is 8 and 9. Okay, number 8 was another composite shape, a rectangle, another rectangle, and then also a triangle. So my first rectangle was 9 by 4. So 9 times 4. My second rectangle was 9 by 8, so 9 times 8. And then our triangle had a base of 9 and a height of 5. So 1/2 times base times height. I found them individually and put them in their shapes. Okay. I like to do that. I like that visual of, okay, the area of this one's 36, the area of this one's 72, the area of this is 22.5, and then I add them together. And then the second one on that page is finding the surface area of the rectangular prism. So again, we squashed it. We made it flat, and then found the area of each of our shapes. And this, when we did that, it folded out into a composite shape. So that's why we started with the composite shape, finding the area of composite shapes, and then moved into the surface area of our prisms. So when we squash it, we can see that there are 6 sides, and then each one of them is labeled with their values. Mrs. Dorn, I have everything. I made the guided ones. I don't know if she gave you one. Oh. So again, flattened it out. Because there's 2 of each type, we put a 2 in front of the area, and I just put that in that calculator to get 424 inches. All right, and then our last problem is our triangular prism. So here was the prism. The triangle had a base of 14 centimeters. Side length is 25 centimeters. The height of the triangle is 24 centimeters. And then the length of the, or the height, I guess you could call it, of the prism is 48 centimeters. So there's my wonderful artwork. Like I said, don't tell our teacher, right? My uncle's an art teacher. He would not be proud. He used to teach kindergarten, first, second grade art. And then, so he taught like 6 to 8-year-olds for the majority of his career. He'd been teaching for 28 years, and they got rid of the kindergarten, first, second grade art program. But because he had been teaching for so long, they moved him to the high school. So he went like from one extreme to the other, and now he teaches like the AP advanced art classes after teaching kindergarten, first, second grade art for 27 years. But he loves it now. I mean, like, he was so nervous. He was like, I'm gonna retire, blah, blah, blah. And I was like, just try it for a year. Like, okay, you gotta do something, just try it. And like, he fell back in love with teaching art. Cause, yeah, so. Yeah. So we've got 4 teachers on my side. And then my nephew's going to school to be a teacher. And my sister-in-law is a teacher. So my other sister-in-law is a nursing instructor. We got lots of teachers. Lots of teachers. You know how that is, Mia. All right, so yesterday we focused on the outside. So we focused on covering the outside of our 3D figures. So I told you when we were talking about this to think about how much it would take to wrap a present or how much it would take to paint a box. That's the surface area of the surfaces. Today we're going to focus on how much we can fit in the box, how much we can fit into our solids. Okay. So that is called volume. So how much will actually fit in this box? How much will actually fit in this cylinder? So that is going to be our focus today. And when we're looking at volume, we are going to look at rectangular solids as well as triangular prisms today. So those are the 2 that we're really going to focus on. So things you'll need out, obviously you have your note packet already out. I see a lot of you have your phones or your computers or your calculators out as well. So make sure we have those items out so we are ready to go. Okay, so like I said, we are focusing on volume. How much fits into our prism? So the formula that we use for volume is base area times height. So V equals B times H, where V equals the volume, B equals base area, and H equals height. So when I say base area, what am I talking about?
The bottom.
Okay, I'm talking about the bottom, the area of the base. So that's what we're going to look at today, and that's what we're going to use today for our values. Important things. So, things that we need to understand before we move on. When I'm talking about the base, our bases are the parallel shapes. Okay? The bases are the parallel shapes. So, which shapes are parallel to each other? So, on a cylinder, my circles are parallel to each other. That means if I were to extend these circles forever and ever and ever, would they touch? No, because parallel lines don't touch. So, on a cylinder, it's really easy to figure out which one are the bases, right? What's the base of a rectangular solid? It can be anything, right? Okay? These two are parallel to each other. These two are parallel to each other. These two are parallel to each other. So it's not so, it's not confusing. You can just really use any of them. The height of a three-dimensional figure is the distance between the bases. So again, the height is the distance between the bases. So you look for the two parallels, and then you find the distance between them. So this measurement here, we would consider to be the height. And then in green, this here, we're going to consider the base. All right, so now we're going to look at our actual formula. Volume equals base area times height. You notice it's a large B, right? Uppercase B? Because they want the whole thing. They want the entire base. So our base area is what shape?
Square.
Careful. It's a rectangle. Why is it a rectangle and not a square?
Because all four sides are equal.
All four sides aren't equal. Opposite sides are congruent. So this is 5 and this is 5, and this is 2 and this is 2. Not to scale, right? So our base is a rectangle. So we're going to have length times width. Okay. So that's our base area. And then we multiply it by the height. If it was a circle, we'd use the area of a circle, pi r squared times height. If it's a triangle, we're going to use half base times height times height. So length times width, 5 times 2. And what's the height of our rectangular solid? What's the distance between our two bases? 8. Five times 2? 10 times 8? So our volume is equal to 80. Area is always squared, right? What's volume? How many units are we multiplying together? Length, width, and height. So that means we're also multiplying centimeters times centimeters times centimeters. So centimeters is going to be raised to the third power. Okay. So volume is always to the third power. So volume is always units cubed. Okay? Now when I say units, I mean that's a specific measurement. So I'm talking about centimeters or feet or inches or miles. Okay? So volume, if we're doing that, we're always talking about, the units are always going to be cubed. So to the third power. Questions so far? What do we see? We see triangles, right? So if we see triangles, then it's a triangular prism. What would we consider the bases? Okay, the end that it sits on, maybe. What shape is in the name? Triangle. So what are the bases going to be? Triangle. They're going to be your triangles. So again, your base is a triangle. So then the distance between the two triangles is going to be the height of your object. Now here's where it gets confusing with triangles. Our formula for a triangle is half base times height. This only is talking about the triangle. This is talking about the height of the figure. So when I look at this triangle, what's my base? Good. And then how tall is the triangle? 6. Does the order matter if I have 6 or 8 first? Nope. Commutative property multiplication says order doesn't matter when we're multiplying, right? So what's half of 8? 4. 4 times 6? 24. So our base area is 24 centimeters. Now again, what's the height of our prism? So our height of our prism is 14 centimeters. So the height of your triangle and the height of your prism are two very different measurements. So we need to really think about that when we're looking at these problems. what'd you get for the prism, for the volume of our prism, our triangular prism? Caleb?
336.
336. Very good. Now that's 336. What's our units? What's our unit? Centimeters. So these centimeters, we multiplied centimeters times centimeters times centimeters, so centimeters cubed. So our volume of our prism is 336 centimeters cubed. So yeah, just make sure we always have our units so we understand what we're measuring. All right, flip it over. What do you see? Squares and triangles? Rectangle in there too? Yeah? What shape is this? I don't know. Is there a name for this? No. But what do you see? We don't have a name for this 3D object. But do we see some things that we might know the name of? Okay, so what do you see, Lil? Okay, so what kind of prism is this? It's okay. Go ahead. Hayden, go ahead.
Triangular prism.
Triangular prism. Very good. It's all right. What is this then? It's a cube. Why is it a cube and not a rectangular solid? Very good. So our cube has equal sides. Our rectangular solid is more elongated. Okay? So we see a triangular prism and we see a cube. Now this is called a composite figure because it's made up of two or more geometric figures. Okay. Yesterday we talked about composite shapes. Today, this is a composite figure. So Saquon has a shed for all his athletic equipment. What is the total volume of the shed? So because we see two shapes, we need to do two problems. Okay. So we have our cube, and then we've got our triangular prism. Oh, come on. That's funny. Okay, so again, volume, base area times height. Base area times height. What's the base of a cube? Okay, yeah, but what shape is it?
Square.
It's a square. So how do we find the area of a square? Length times width, right? So volume is equal to length times width times the height of our cube. What's the length? 18 feet. What's the width? What's the height? Very good. So we've got length, width, and height. And all those measures are 18. So the volume of our cube is 18 times 18 times 18. volume just of our cube? Okay? Very good. 5,832. And because our measurement is feet, we're going to go feet cubed. Okay, so again, for our triangular prism, volume is equal to base area times the height. What shape is the base of a triangular prism? A triangle. So our base area is going to be half base times height, and then times the height. Again, the height of a triangle is different from the height of the three-dimensional figure. So here's the base of our triangle. What's the measurement of the base of our triangle? Not what I wanted to do. Here's the base of our triangle. What's that measurement? 18. How tall is the triangle? So just the triangle. How tall is it? It's 10 feet. Now again, the height is the distance between the two triangles. So look for the distance between the two triangles. 18, very good. Can you put this into your calculator as one expression? Yes. Absolutely, you can. You could do it individually, do it by the parentheses, bring the value down, and then multiply by the height, or you can just stick it in all at once. Just make sure you have your parentheses. We practiced that yesterday. Those parentheses can make a big deal. Hold on. Let me just fix it for you. I'm just going to delete this. Not sure. There you go. If you have a parentheses here, Hayden, you need a parentheses, another one that matches over here. So what's the volume of our triangular prism? Very good, 1,620. What am I going to do with the volume of the cube and the volume of the triangular prism? To get my total area? Add them together. So my volume of my cube is 5,832. The volume of my triangular prism is 1,620. So we want the total area of Sequan's shed. They give you names like Myrtle, Bob. Oh yeah, yeah. $7,452. Yeah. I made a mistake right here. I put squared instead of cubed. Ruh-roh. Ruh-roh. Again, it's all about breaking things down and what we know. We know area of a rectangle, area of a square is length times width. We know that a triangle is half of a rectangle or half of a square. So it's just using that information and being able to apply it in these problems. All right, last one. Amber, see, that's one I can get on board with. Amber built a custom terrarium for her plants. What is the volume of the terrarium? Do you have a formula for this shape? Do you have a name for this shape? No, I don't. Right? What do you see? You see rectangles? Everyone else see rectangles? So can we maybe break this shape into rectangular solids? Yeah, we can break this into two rectangular solids by doing this. So what we've done is we've created one rectangular solid and a second rectangular solid, so that then we can find the volume of the solid. What now do we need to be careful about? What do you mean there's two different tops?
Well, there's like a part and then it's two different because it has a little part and a high part.
Okay, all right. What about our measurements? Do we just use the measurements that are up there and we're good?
No.
Okay, so what do we need to do? What's wrong, Addison? Okay, so what I'm referring to is that because I split this into the first rectangular solid and the second rectangular solid, this entire measurement is 40. But I need to know just this measurement here, from here to here. Okay? Because now this is a rectangular solid that I'm finding the volume of. And then this here is another rectangular solid that I'm finding the volume of. Okay? So my measurements are going to change a little bit because I've shortened 40 inches by this much. Okay, Mia?
We're going to do 40 minus 10.
Very good. So this right now, the whole thing is 40, but I only want this piece because this is 10. This then becomes 30. So I need to find the volume of a rectangular solid 1, and I need to find the volume of a rectangular solid 2. So my volume is equal to base area times height. What's the base of the first rectangular solid? What shape is it? This one right here, what is this? It's a square. Okay? So, what are the sides of our square? 10. So our base is 10 times 10. What's the distance between those two bases? 30. Very good. Times 10? 100? 100 times 30? 3,000. Now we've got rectangular solid number 2. Again, volume is equal to base area times height. What's our base? What shape is this? Not square this time. It's a rectangle because our shapes, our sides are different. We've got a side of 10 and a side of 12. So again, that's a rectangle. What's the distance between those two smaller rectangles? 30. So what's the volume of the second prism? Tay? Say it again. There you go. What am I going to do those two? Very good. Anytime we have composite figures, we add our volumes together, just like we added our surface areas together yesterday. So our volume is 6,600 inches cubed. Okay, your homework, 3 problems on the back. Have a wonderful weekend, guys.